Inside Mars Rovers, the technology that explores the red planet Mars. Cold, dusty, deadly. Yet for decades, humanity has been sending little robots to live there, exploring, driving, drilling, and discovering the secrets of the red planet. Today, we're cracking open the secrets of these mechanical explorers, how they move, think, survive, communicate, and send jaw-dropping images across millions of kilometers of space. The birth of a Martian explorer. Before we go deep, let's get this straight that a Mars rover isn't just a robot car, it's a mobile science lab, engineered to survive a planet that's trying to kill it 24/7. The first rover, Sojourner, was landed in July 1997, small, simple, solar-powered. It proved one thing, that we can move on Mars. Then came the twins Spirit and Opportunity, rolling in 2004 with 6-wheel drive and panoramic cameras. They were expected to last 90 days, surprisingly, they lasted years. And then, Curiosity was landed in 2012, nuclear-powered, car-sized, and loaded with a full-on chemistry lab. Finally, in 2021, Perseverance joined the crew, AI-powered, sample collecting, and even brought a helicopter buddy, Ingenuity. From toy-sized Sojourner to high-tech Perseverance, the evolution of Mars rovers tells one story, that we're getting smarter, faster, and bolder. Design and mobility. All right, let's talk hardware. Mars rovers are built like mountain goats with PHDS. They use a rocker bogie suspension system, a clever design that lets all 6 wheels stay in contact with the ground while climbing over rocks up to 75 centimeters high. No shocks, no springs, just pure mechanical genius. Each wheel has its own motor, and modern rovers like Perseverance can turn their front and rear wheels, allowing them to spin a full 360-degree, crab walk, or wiggle free if they get stuck in sand. Under the hood, a chassis made of aluminum and titanium, lightweight but strong enough to survive impact, dust storms, and decades of wear. It houses the central computer, power systems, thermal units, and scientific instruments. Every gram counts on interplanetary missions, so the design has to be compact, efficient, and nearly indestructible. Sun versus plutonium. Mars is far from the sun, and sunlight there is weak, only about half of what we get on Earth. Early rovers like Spirit and Opportunity use solar panels to power up, but there's a problem: dust. That fine Martian powder covers everything. One big dust storm and poof, no sunlight, no power, mission over. That's exactly what happened to Opportunity in 2018. After nearly 15 years of incredible service, the planet's biggest dust storm blocked the sun for weeks, and Opportunity's final message was heartbreaking: "My battery is low, and it's getting dark." To fix that issue, NASA switched to nuclear power. Curiosity and Perseverance run on RTGs, radioisotope thermoelectric generators. They convert heat from decaying plutonium-238 into electricity, giving the rover steady power 24/7 and enough warmth to survive nights colder than Antarctica, 1130 to 1140. Nuclear power provides constant energy and self-heating, resulting in a happy rover. Brains of the operation, computers, and autonomy. Now here's the mind-blowing part. Mars is really far away, between 54 and 400 million kilometers. So when you send a signal, it takes between 3 and 22 minutes to reach the rover. That means you can't joystick drive a Mars rover. It has to think for itself. Each rover carries a radiation-hardened computer, not fast, but extremely reliable. Curiosity's brain is a RAD 750 processor, roughly the power of a late 1990s laptop, but it can survive solar flares and cosmic rays. The real magic is in the software AutoNav. AutoNav lets the rover scan the terrain with stereo cameras, build a 3D map, and pick safe paths without human input. Perseverance even uses AI to identify rocks worth studying. It's basically doing field science on its own. That's like giving a robot a PhD in geology and letting it wander another planet unsupervised. How they survive. Mars wants to kill them. Mars is brutal. The atmosphere, less than 1% of Earth's. The temperature, down to minus 80 degrees Celsius at night. The radiation, constant cosmic assault. So how do these robots not freeze, fry, or fall apart? They have a built-in thermal control system, heaters, insulation, and radiators. Some rovers even pipe warm fluid through the chassis to distribute heat evenly. The electronics are tucked inside a sealed, radiation-shielded box, sometimes called the warm electronics box. And dust, that clingy, electrostatic dust, is everywhere. Engineers design rovers with sealed joints, brushes, and clever self-cleaning systems. Fun fact is Opportunity's solar panels were often cleaned by dust devils, literal Martian mini tornadoes that blew dust right off. Talking to Earth interplanetary communication. So how do these robots send selfies from 200 million kilometers away? They use a combo of antennas and orbital relays. Each rover has a high-gain antenna for direct communication with Earth, a low-gain antenna for emergencies, and most importantly, a UHF antenna that talks to orbiters like the Mars Reconnaissance Orbiter. Those orbiters then beam the data back to Earth using NASA's Deep Space Network, massive 70-meter radio dishes stationed in California, Spain, and Australia. That's how a tiny robot on another world uploads high-definition photos, weather reports, and science data across deep space. Data speeds? Think dial-up internet, about 32 to 256 kilobits per second. So each image can take hours to fully transmit. But when it finally arrives, it's magic. Eyes and instruments. Let's talk about the eyes and tools that make rovers so powerful. Perseverance has 23 cameras, yes, 23. Some are for navigation, some for science, and some just for epic selfies. Mastcam Z gives high-def panoramic views with zoom, 1047 to 1053. Its SuperCam fires a laser to vaporize rock samples and analyze their composition. Rovers have two microphones, one on the mast and second on the side of rover. Then it comes with front and back HazCams to help in avoiding hazards while driving on Mars, and NavCams map terrain for safe driving. MEDA sensors track weather and atmosphere. PIXL, Watson and Sherlock cameras examine rocks at microscopic detail. And then there's the coring drill, a robotic arm and drill that collects rock cores and seals them in titanium tubes. Those samples will be picked up by a future Mars sample return mission, bringing pieces of Mars back to Earth for the first time. That's history in progress. Here's how the data flow works. The rover gathers info, stores it in onboard memory, then waits for an orbiter to pass overhead, then beams the data up via UHF. Then orbiter sends it to Earth and NASA decodes it. Finally, scientists and the public get it. It's a daily digital relay race across space. Those stunning 360-degree panoramas you've seen, they're actually hundreds of images stitched together. Every photo represents careful planning, transmission, and processing, a blend of art and engineering. From Sojourner to Perseverance, evolution of a legend. Each rover generation has built on the last. Sojourner, 1997, proof of concept. Could we even drive on Mars? Yes. Spirit and Opportunity, 2004, the endurance champions. They found proof that Mars once had liquid water. Curiosity, 2012. The lab on wheels that detected organic molecules and radiation levels. Perseverance, 2021. The scientists collecting samples, testing life support systems, and even launching the first helicopter flight on another planet. Every rover isn't just exploring Mars, it's preparing for us, for the day humans finally walk on the red planet. What's next for Mars exploration? The future of Mars exploration is already in motion. NASA and ESA are planning the Mars Sample Return Mission, which will bring Perseverance's samples back to Earth. Engineers are designing laser communication systems for faster data transfer, self-healing materials, and mini-swarm rovers that can explore together like robotic ants. Artificial intelligence will play a bigger role too, identifying interesting rocks, making navigation decisions, and even choosing where to drill all without waiting for Earth's approval. We're heading toward a future where Mars rovers don't just follow orders, they lead the exploration. From the first tiny rover that rolled a few meters to today's nuclear-powered explorers drilling ancient riverbeds, Mars rovers are humanity's greatest robotic achievements. They think, they adapt, and they endure. They are our ambassadors on another world searching for the answer to one question that defines us all. Are we alone? Thank you for watching. If you liked the video, don't forget to like, share, and subscribe.